Ear damage from diving. If the force on the tympanic membrane, the eardrum, increases by about delta F of 1.5 newtons above the force from atmospheric pressure, the membrane can be damaged. When you go scuba diving in the ocean, below what depth could damage to your eardrum start to occur? The eardrum is typically D is equal to 8.2 millimeters in diameter, and the density of seawater is 1.03 10 to 3 kilograms per meter cube. Now we know that the pressure at a depth h in the ocean is the atmospheric pressure P0 plus the density, gravitational acceleration, and the depth h. So delta P, the gauge pressure, is rho gh, which is equal to the delta F, the additional force per area, and this tells us that the depth is related to delta F as delta F divided by rho g area A. Now what is this area A? It's the cross-sectional area of our eardrum, which is pi r squared. It has a diameter d, so this is basically the diameter d divided by 2, that's the radius squared. So the area is pi d squared over 4. So if we substitute this here, we will obtain h is equal to 4 times delta F divided by pi rho g d squared. So this rho is the density of the seawater. So we call this rho. Okay, so if delta F is equal to 1.5 newtons, that's going to damage our ears. And the density of seawater is 1.03 10 to 3 kilograms per meter cube. The gravitational acceleration is 9.8 meters per second square, and the diameter of the eardrum is 8.2 10 to minus 3 meters, so it was 8.2 millimeters. We can substitute these numbers to calculate the depth where this damage will occur. So h is equal to 4 delta F, so 4 times 1.5 newtons divided by pi density 1.03 10 to 3, density of seawater, pi rho g, g is 9.8, and d squared, which is 8.2 millimeters, 8.2 10 to minus 3, parentheses squared, and this gives us a depth of 2.8 meters. Okay, so below 2.8 meters in the ocean, there will be a permanent damage to the eardrum from diving. Okay, so this question was about ear damage to that can occur during diving. An additional force above the force from atmospheric pressure of 1.5 newtons can cause ear damage. And when we go scuba diving in the ocean, there is a limit, a threshold depth below which this damage will occur. So we want to find out what that threshold depth is, knowing that the diameter of the eardrum is 8.2 millimeters and density of seawater is 1.03 10 to 3 kilograms per meter cube. We know that the pressure as a function of depth increases by an amount, rho gh. The gauge pressure, the pressure above the atmospheric pressure, is rho gh, which is the additional force divided by the area A. The cross-sectional area of the eardrum is pi d over 2 parentheses squared, pi r squared, assuming that it is a nice circle. So we have pi d squared over 4, which we substitute here into this expression for h, delta f over rho ga. We find 4 delta f over pi rho g d squared. If we substitute the given numbers, we find that threshold depth is 2.8 meters.